Hello everybody, Mr. Schultz here. Make sure you put 1-3 in the top left hand corner, and in the top right hand corner you write your information. Now we are on lesson 1-3, properties of real numbers. So here is the information. Reflexive property. Any quantity is equal to itself. What does that mean? Well, for any number a equals a. Well, what does that mean? Well, 5 equals 5. What if we put negative 42? Well, if we have negative 42, that's equal to negative 42. What if we had x? Well, then x is equal to x. That's all it's saying. It's equal to itself. Done. Now the symmetric property is a little bit more complicated. Let's write it in. If one quantity equals a second quantity, let's spell that right, quantity, then the second quantity equals the first. What does this mean? Okay, for any numbers, let's write the symbols. For any numbers a and b, a is equal to b. Oh, no. If a is equal to b, then b is equal to a. What does that mean? Okay, that's basically saying, hey, look, if I have 3 plus 4 is equal to 7, then I should know that 7 is equal to 3 plus 4. If my, well, for you it looks like my right hand. If my right hand is equal to my left hand, then my left hand will equal my right hand. You could switch right over the equal sign. All right, let's go on to the transitive property. I like this one because we're building. First we said, hey, it's equal to itself. Then we're saying, okay, if this is equal to this, then we could switch them in the equation. This next one is if we have 3 quantities. If quantity 1 equals quantity 2 and quantity 2 equals quantity 3, then quantity 1 equals quantity 3. Well, let's write out the symbols. For any real numbers a, b, and c, if a is equal to b and b is equal to c, then a has to equal c. Transitive. Well, let's fill this out. I understand that 5 plus 1 is equal to 2 plus 4. And I know that 2 plus 4 is equal to 6. Without having to figure anything out, I know that 5 plus 1 is equal to 6. Without even adding 5 and 1, I know 5 plus 1 is equal to 6 because 5 plus 1 is equal to that, and 2 plus 4 is equal to that. Therefore, they're all equal to each other. The end. All right, let's go on. We're going to be talking about the additive identity property and the additive inverse property. in 3, 2, 1. All right, the additive identity property is going to be where, for any number, real number A, the sum of A and 0 is A. Okay, well, what does the symbol look like? Okay, let's write it in. A plus 0 is equal to 0 plus A, which is equal to A. In either of these cases, look, hey, this will equal 0, or this will equal A, and this will equal A. Whichever, like if they were moved around, doesn't matter. It's equal to A. Well, let's think about this. 5 plus 0 is equal to what? 5. How about this? 4 plus 0, what's that equal to? 4. Okay, what about negative 3 plus 0? What's that equal to? Negative 3. This is the additive identity property. Think of, hey, what makes this number this number? What do you add to make this number equal itself? 0. Okay, additive inverse. Okay, for this one, we have a real number and its opposite are additive inverses of each other. What does this mean? Well, let's write in our symbol. A plus negative A will equal 0. They cancel out. Okay, well, what's the example? Or the real world example? Well, not real, but number-wise. 5 plus negative 5 equals 0. What if I had negative 6? What's the opposite of that? Negative negative 6, or positive, will equal 0. In each of these cases, the inverse is, hey, what cancels this out? And if we're adding to cancel out, we want to get it to 0. Okay, now we're going to do the multiplicative identity and inverse in 3, 2, 1. All right, so the multiplicative inverse property, oh no, that shouldn't be inverse, that should be identity. So let's write this in right here. Let's do our drawing. This should be identity. So what makes this number this number? Well, let's write it in.